Hello, and welcome to more graphing rational functions. So the next function we're going to look at is f of x equals x squared minus 4 divided by x. And remember, we start with domain. So D for domain. We notice that x cannot equal 0. Next, we check to see if we can reduce. Well, the numerator factors into x minus 2 times x plus 2, but we'll notice there's no common factor because this factor that contains an x is x minus 2, not x, and we reduce by common factors, not terms. So it doesn't reduce. Okay, for our intercepts, our x-intercept, we will let y be 0, and we'll graph the ordered pair that we find. So letting y be 0, we get x squared minus 4 divided by x. Multiply both sides of the equation by x and clear fractions. Recall we can clear fractions because we have an equation. So the x is reduced, and I have 0 equals x squared minus 4, but x squared minus 4 can be factored into x plus 2 times x minus 2. Then let each factor with an x equal 0, and we'll find a couple of x's. So x equals negative 2 or x equals positive 2. So there are our x-intercepts. So we'll be graphing negative 2, 0, and 2, 0. Then for our y-intercept, we'll plug in 0 for x, and when I plug in 0 for x, I get 0 in the denominator, so I don't have a y-intercept. Then we'll check for symmetry next. So let's clear off a place to look for symmetry. Okay, to check for origin symmetry, and I'm going to check for that first because I know that's what we have here, and you may be able to see that now. We will use opposite of x for x and opposite of y for our y. So opposite of y, and this is our new y, equals opposite of x squared minus 4 divided by opposite of x. So minus or opposite of our new y equals x squared minus 4 divided by opposite of x. But we don't want the opposite of our new y, we actually want our new y, so we'll multiply by negative 1 on both sides. Now think a minute. I'm really wanting to work on this minus because it doesn't match this x up here. So I'm going to multiply by 1 divided by negative 1 for my negative 1. So I get my new y equals x squared minus 4 divided by negative times negative is positive, which is x. And that is my original f of x. So I have origin symmetry here. And you will get to where you can notice what symmetry you're going to have. I noticed it because I knew x squared would give me minus x squared would be the same thing. But I plug in minus x down here and I have one little sign change, and I knew I could take care of that by multiplying by negative 1. Okay, let's get a little more space here. We have x squared minus 4 divided by x for our f of x. And let's see, D-R-I-S-A, asymptotes. Vertical asymptotes. Remember, we found that x could not equal 2 and x could not equal negative 2, and they didn't reduce away. So our vertical asymptotes are at x equals 2 and x equals negative 2. Well, let's see if we have a horizontal asymptote. I divide lead term into lead term. Uh-oh, it doesn't go a constant number of times. So what does that tell me? Well, let's reduce this. I can reduce it easiest by saying x squared divided by x minus 4 over x, and I get x minus 4 divided by x. So my f of x could be written this way. Now think a minute. As x goes to infinity, 4 cakes is not much for an infinite number of people. So this is approaching 0. That means our y is approaching x. So as x goes to infinity, y goes to infinity. What's that the equation of? That's the equation of a line, isn't it? Because we have y to the first power, x to the first power, and it's not a horizontal line, is it? It is a slanted line. Therefore, instead of a horizontal asymptote, we have a slant asymptote. So let's write down our asymptote, but let's erase horizontal asymptote and use slant asymptote, since this is the first time we want to abbreviate it. So our slant asymptote is y equals x. Okay, and then we want to know if it crosses an asymptote. It will not cross the vertical, remember, so we want to know if it crosses the slant asymptote. The way we do that, we say the y of the asymptote equals the y of our main function, and see if we have an x that's common to both of them. So we're going to let x equal x squared minus 4 divided by x. We'll clear our fraction by multiplying by x on both sides, and we get x squared equals x squared minus 4. So subtracting x squared from both sides, we get 0 equals negative 4, which is always false. So no, there's no common x when we set our y's equal. So there's no point with common x's and y's. Let's move to our graph now, and then we'll get the last part, A, for additional points, when we see what additional points we actually need. So let's graph what we have. We have 2 and negative 0 for intercepts. 2 and negative 2, rather. Okay, so we have our x-intercepts graphed. Next, we're going to graph our asymptotes. We have x equals 0 as our vertical asymptote. And then our horizontal asymptote is y equals x. So we'll have 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, so forth. And then we'll dot in that line. Dot it maybe a little further. Okay, that's our asymptotes. What else do we know? We know that we don't cross the asymptotes anywhere, so that's important information to know. Next, let's see what additional points we want. So over here, we'll pick up some points. We'd like at least 2 points on the left side of our vertical asymptote. So for the left side, why don't we pick positive 1 rather? No, for the left side, we will pick negative 1. And for the right side, we'll pick positive 1. And then if we're not happy, we'll pick another point or 2. So when I plug in negative 1, I get 3. Since we have origin symmetry, I know that when I plug in positive 1, I will get negative 3. So let's see how that looks. 1 and negative 3, here it is. And negative 1 and positive 3 right here. I think I might like to go on one more. Let's go to -3 and +3. When I plug in 3, I get 5/3, which is 1 2/3. So I think I'll write it as -1 2/3 for my -3. All right, so -3, 1 2 3, -1 2/3, then +3, 1 2/3. I think that's probably enough to sketch it since we know we're headed toward the asymptotes and that we don't cross them. Okay, so head toward the asymptotes, head toward the vertical asymptote, head toward the slant asymptote. And there is our graph for f of x equals x squared minus 4 divided by x. So we picked up a slant asymptote as opposed to a horizontal asymptote this time for the first time. All right, let's move on. Find us another graph. This time we're going to graph y equals, or f of x equals, x squared minus 3x plus 2 divided by x plus 1 quantity squared. So for our domain, we know that x cannot equal -1. Does it reduce? Well, let's factor the numerator and see. What about x times x to get x squared, both negative, to get a positive here and a negative middle term. Use 2 and 1. And now let's check our middle term. -2x minus x, yeah, that gives me a minus 3x. So it did factor in the numerator, and I've got 2 factors of x plus 1 in the denominator. But when I look, there's no common factor, so no, it doesn't reduce. For intercepts, let's plug in 0 for y and 0 for x and see what happens. So first of all, doing 0 for x, we get 0 plus 0 plus 2 divided by 0 plus 1 quantity squared. So that'll be 2. 0, 2 is an intercept. Then let's plug in 0 for y and see what we get for our x. So 0 equals x squared minus 3x plus 2 divided by x plus 1 quantity squared. To clear my fractions, I'll multiply by x plus 1 squared. Have to do it to the other side of the equals. All right, and of course I get 0 on the left. The x plus 1 squares divide out, and I have x squared minus 3x plus 2. Oh, well, this is nice. I've already factored this one, so I know the factors, x minus 2 and x minus 1. So if I let x minus 2 equal 0 and x minus 1 equals 0, I'll get me some x's. So x equals 2, x equals 1 for my x-intercepts, which means I'm going to graph 2, 0 and 1, 0 when I get ready to graph. Next, we'll check for symmetry, and we've done that several times. And I can kind of look at this and tell there is no symmetry. I hope by now you're getting to where you have a feel for that symmetry also. So checking for y-axis symmetry, I will say my new y equals, and I'll plug in opposite of x everywhere I have an x. So my new y is x squared plus 3x plus 2 when I do the arithmetic, divided by opposite of x plus 1 squared. Well, that does not equal my original f of x, does it? So there is no y-axis symmetry. So next we can check for origin symmetry by letting the opposite of our new y equal what I got when I plugged in opposite of x, because I am plugging in opposite of x and opposite of y both. So x squared plus 3x plus 2 divided by opposite of x plus 1 squared. If I multiply both sides by -1, I will get just my new y on the left. And I think I'll do plus 1 divided by -1 over here, so that this right here will become a plus. So I'm going to write it above here since I've run out of space and don't want to bring up a new slide quite yet. So moving upwards here, I end up with my new y equals, numerator stays the same, denominator becomes x plus 1 squared when I multiply negative times negative. Okay, the denominator is the same as f of x's denominator, but the numerator differs by just that sign. So no, we do not have origin symmetry either. So our answer for symmetry is no. We've checked for both kinds of symmetry that we might have with a function and came up with none. Okay, let me rewrite our function here on our new slide. We have x squared minus 3x plus 2. And I'm going to write the denominator already multiplied out as x squared plus 2x plus 1. And now we had finished symmetry and found none. We had done our asymptotes, and we're down to does it cross an asymptote. Now remember that y equals 1 was our horizontal asymptote. So let's let the y here equal the y here. So this y and this y together. And if the y's can be set equal and we find an x, then we know we have a crossing point. So x squared minus 3x plus 2 divided by x squared plus 2x plus 1 equals 1. To clear our fraction, we'll multiply by x squared plus 2x plus 1 on both sides of the equals. And of course, the x squared plus 2x plus 1 in the numerator and denominator reduced to 1. So I have x squared minus 3x plus 2 over here, and 1 times the polynomial is that same polynomial on the left side, right side. So let's subtract x squared now from both sides. And our x squares add out over here, and we have minus 3x plus 2. Well, guess what? They add out over here too, and I have 2x plus 1. So I'm down to a linear equation where I would like to have all the x's on one side. So we'll subtract 2x from both sides and get minus 5x plus 2 equals. Check our arithmetic. Don't assume it's going to work because we could have thought backwards. It does work, and it equals 1 for us. And now, if we subtract 2 from both sides, we'll get our x term isolated. So 1 minus 2 is -1. Then divide by -5 to get the coefficient of x to be 1, and x equals 1/5. It does cross our asymptote where x is 1/5. I wonder what y was. Oh yeah, look back in this equation. Y equals 1. That's what we substituted in for y. So our crossing is 1/5, 1. All right, let's get ready and graph, and then we'll see what additional points we want to use. Okay, what do we have so far? We have 0, 2. We have 2, 0. and 1, 0. And we have asymptotes at x equals -1. And at y equals 1. And we have that we cross the horizontal asymptote at 1/5, 1. So come over about 1/5, go up 1, and that's where we cross it. Okay, what are we going to do here? Well, I know I've got probably enough points most of the way here on the right side. It's the left side I need to work on. So let's plug in -1, then -2, -3. We know we don't cross -1, so we won't list it. So -2 and -3. Now you know what? I'm really worried about what happens on that x-axis because I already know that thing's not going to turn around and go back up through the horizontal asymptote because I found all the crossings. So what does it do right in here? What would it do? It is either going to peek out or bottom out and then start back toward the asymptote. Has to. I think we might need the calculator to find either that point or this point because we know as it gets far enough out it heads toward the horizontal asymptote. But we just don't know what it does right here. So let's erase our doodling here. Redraw our points, which were 2, 0, and 1, 0. And let's go to the grapher to help us a little bit get this part right in here taken care of, right between x is 1 and x is 2. And since we're going to do that, we might as well let the calculator give us the y values here for -2 and -3 for x. I mean, why don't we get lazy here? So let's go to our calculator. Okay, going to our y equal here, we'll type in our function. So y equals, now we're going to have to put the whole numerator in parentheses and the whole denominator in parentheses if we want this to come out right. Otherwise, the calculator will think it divides at a different spot than it actually divides. So parentheses for the numerator, and then we'll do x to the second minus 3x plus 2, close parenthesis for the numerator, divided by, and then open parenthesis for the denominator, x plus 1, in parenthesis, to the second power. And when we graph, we do see that little blip here going through 1 and 2. Now, how did I get that? Let's go back to our standard screen. Look at it there, and then we'll zoom in. You can see that we can't really tell what's going on there with our view that we have. What we can do is get some values over here that we might like to have. So let's go to second table, and let's write -4 as 3.3. We'll add to our list a little bit. Let's do -3 as 5 and -2 as 12. And then I'm going to go back to the graph screen, and I'm going to put on my trace, and I'm going to move over until I get between 1 and 2 for x, and then I'm going to go to zoom in at that point. So zoom in is selection 2, and I'm going to hit enter, and we'll see what's happening. Well, we can see a little bit of what's happening. Let's zoom in again. So let's see where our cursor is. I'm pretty happy with it there. So let's go to zoom, zoom in again. That is selection 2. Hit enter. And now we can see that pretty well, can't we? We need to name that point right in here, our minimum point. So let's go to second, calculate, and let's go to number 3, minimum. Let's get way away from it here. Hit enter because we're to the left. Then go way to the right here. Make sure it's coming back up before we stop. And hit enter again. And now let's see what we have. We have the minimum point as negative 1.4 and the y as negative 0.04. So 1.4 negative 0.04 for us. So now we know what we're going to graph. So let's go back to our graph screen now and graph it. So the points we picked up. For negative 2, we picked up 12. And for negative 3, we picked up 5. And we decided to do negative 4 while we were there, which was 3.3. So let's graph those. Negative 2, 12 is way above our screen. It's way up in here, so we'll head toward it right there. Let's get it more on negative 2. So we'll just head for it above our screen somewhere. All right, and then we have negative 3, 5. So 1, 2, 3, and then up 1, 2, 3, 4, 5. And then we have negative 4, 3.3. 1, 2, 3, 4. 1, 2, 3.3. So I think that what we can do now is just draw, because we know we're headed toward our asymptote. We're headed up pretty steeply, and we'll just sort of gradually move down here. If I wanted to get 1 or 2 more points, I could and make it a little more exact, but we're just doing a sketch, so I think we'll stop right there. Then over here, what we needed to know was what was happening between our 1 and our 2 for x, and we found that out. We found out that we're going to have 1.4 and negative 0.04. So I come over here to 1 and close to a half and negative 0.04 here. And I think I can draw it now because I know what's happening. I'm going down here rather than making a loop up. And then I'm heading back toward my asymptote without crossing it, because we already know where the 1 crossing is. So that's another graph of rational functions. We'll probably look at one more graph and an application next time.